All right, so to balance, pretty much the same thing as before. We're going to split the equation down the middle where the arrow is. We have zinc, we have hydrogen, and we have chlorine. Okay, so this part should be pretty simple now. We've spent about 3 days working on just balancing. It's where we count the elements and try to make sure we got the same number on both sides. Okay. All right, so if you take a look at the left side is pretty easy, right? There's 1, 1, and 1, so we got one of each. Okay, but if we look at the right side of the arrow, we got 1 zinc, we got 2 chlorines, and we got 2 hydrogens. All right, so I'll pause right there. Any questions how we got the counts for each of the elements? Hopefully that part's not too bad. All right, so it looks like we're not balanced with hydrogen and chlorine. And if you guys look, we need more of each on the left side, right? Luckily, we only need one more because we got to get from 1 to 2. And we have a molecule that has H and Cl inside of it. So we're going to add another HCl. That's going to change our hydrogen number on the left to 2 and our chlorine number to 2. Okay. And then we're all balanced. So all you got to do is put a 2 in front of HCl. If you want to plug in the ones right here, just so that you guys fill in all the blanks you can, but that's how you balance the. All right, any questions on the balancing? Pretty simple. For your assignment problems, the balancing won't be too difficult. I'll try to keep it pretty simple for you guys because we have a lot more calculating to do. So today's the day we start actually doing a good amount of math. I know, unfortunate. All right, so we're going to do the second part, which we learned last class. We're going to do the molar mass. So I'll give you guys a second to do that because the molar mass should be pretty simple. I want you guys to find the molar mass of zinc and H2 and just write it somewhere on your paper. Okay, so write down the molar mass of zinc and H2. You will need your periodic table, so just make sure you guys have that out. You'll also need a calculator today. Phone is totally fine, so just make sure you guys have that handy. Give you guys like a minute to do those two, and then we'll move on to the new info for today. Simple. All right, so for the molar mass of zinc, if you look, zinc is just one element, right? So we're going to go to the periodic table and look that up. So if we go to the periodic table and look for zinc, you'll find it in the middle, kind of on the right side. And if you guys remember, molar mass is the number at the very bottom. So zinc is going to be 65.39. Okay, so we're going to write down that zinc has a molar mass of 65.39, and we're going to write grams equals 1 mole. Okay, so don't forget that. We need to add that for molar mass. Okay. So zinc has a molar mass of 65.39 in 1 mole. Okay. All right, let's do H2 now. H2 is also pretty simple. It's made out of 2 hydrogens. So we're going to look at hydrogen on the periodic table. It's going to be 1.01, but there's 2 of them, so we can add them together or multiply by 2. And that'll be 2.02. So the molar mass of H2 will be 2.02 grams in 1 mole. Okay, so that's going to be the molar mass for those 2. Thank you. And make sure you guys have these jotted down because we will be using this problem in order to solve our first sample problem. If you guys take a look at the title of the lecture, it's called Intro to Stoich. Okay, so Stoich is short for this term called stoichiometry. If you guys take a look on Canvas, your assignment is called Intro to Stoichiometry, but that's a big, long word, so we just write Stoich. Let's talk about what Stoich is, because it's pretty much the main thing of chemistry for our class. So stoichiometry, I do want you guys to write this definition down. It's right here. It's using conversions, so you know the fractions that we learned last time. It's using those fractions or conversions to determine how much product, so how much of a chemical you can make using your starting reactants. So depending on how much starting chemicals you have, how much product chemicals can you make? Okay, so that's what stoichiometry is. It's using conversions or the fractions, using math to figure out how much of a product you can make using a certain amount of reactants. All right, so if we think about this practically, how we're going to use it in the class. So like I told you, going forward, I'm going to give you guys chemicals for your labs. So basically, stoichiometry is you're going to weigh out how much chemicals I give you, and then you're going to calculate how much of a different chemical you're going to make. That's what stoichiometry is. It's just predicting how much of a product you're going to make. All right, so there's 3 steps, and I do want you guys to write this down because it'll be helpful because you can always refer back to it when you guys are solving these stoichiometry problems. And the first 2 steps we already learned how to do, and we did it in our warm-up. The first step is you just balance the chemical equation. So just regular balancing. You're going to get an equation, just balance it. Okay, step 2 is you want to find the molar mass of the involved compounds. I'll talk about what the involved compounds are in a second, but it's just finding molar mass. And after that, it's my favorite thing in the world. You're going to do some math, and that's what we're going to learn today. Okay, so you guys already know how to do 2 of the 3 steps. The only one that we're going to learn today is the math component. Okay, we're just adding that on. Okay, so I'll give you guys another minute to copy down the steps. You guys don't need to copy down this problem because this is actually what we solved in the warm-up, so you can just leave that alone. But we'll get started in about 2 minutes. Okay, so we did most of what we're supposed to do. We just need to do this 3rd step. Okay, so don't copy this down yet. I'm going to talk about what we're going to be doing for stoichiometry, but let me give you guys a scenario of what we're going to do. So this is the chemical equation that we balanced, and so we're actually going to run this equation in class today. Okay, so in this equation, it's telling us we are mixing zinc and HCl. Okay, so up here I have, you guys take a look inside the container. You see this metal. It looks like foil, but this is zinc. I just have it ripped up so it's easier to work with. And then what we're going to do is we're going to combine it with HCl. Okay, so I'm going to pour some HCl in there. And when the reaction goes, it's going to make 2 other chemicals. It's going to make ZnCl2, and it's going to make this thing called H2. Now, H2 is a gas, and so what I'm going to do is I'm going to capture it using a balloon. So, 1 second, I need to pour a little bit more. Okay, but we're going to add some HCl to the Zn. All right, and then it's going to take some time to react, and as it reacts, it's not interesting right now, but as it reacts, we're going to be solving this problem. But what should happen is the Zn inside the container is going to mix with the HCl, and you're going to make those 2 chemicals. Okay, and then the H2 is a gas, so you guys should see it start to get captured inside this. Okay? All right, so that's the chemical reaction, but let's talk about how we can figure out how much H2 we're going to make. So if you guys take a look at the problem tells you there's 10 grams of Zn. So I put 10 grams of Zn inside this container, and then we combined it with excess HCl. Okay, now on your paper, I want you guys to make a quick note. I want you guys to write the word excess. Okay, and what excess means is you have so much that you don't need to worry about. Okay, so you can just write so much, but if you ever see the term excess in a chemistry class, it just means you have so much of that chemical you don't need to worry about it. All right. So what I did was I put 10 grams of Zn in there, and I put a lot of HCl so that you don't need to worry about whether you're going to run out or not. Okay. And then the question is asking how many grams of H2 gas will be produced. So what we're trying to find is how much H2 we can make using our 10 grams of Zn. Okay. So in this problem, if you guys remember from step 2 was finding the involved compounds. You're always going to have 2 involved compounds in these problems. Okay, the first one is the chemical that you start out with that you have a limited amount of. So our first chemical that we're starting with is Zn. Okay, and then the second compound is the one that you are trying to make. So in this problem, the first chemical that's important is Zn. And the second chemical that's important is H2. And that's the reason why earlier in the warm-up, we found the molar mass of Zn and H2. That makes sense? Okay, so we start with 10 grams of zinc, and we're trying to find H2. That's why these 2 are the important chemicals. So going forward, we don't need to worry about HCl, and we don't need to worry about ZnCl2. We're not thinking about those now. We're just looking at these 2. Okay? All right, so let's do the math. So in order to do the math, we need the setup. So I want you guys to copy down the setup. Okay, these are fractions, and so just make sure you leave enough room to write numbers and other things on it. So I'll give you guys about a minute or two to copy that down. You will be expected to memorize it towards the end of the unit. For now, you don't need to worry though, okay? I will give this to you in the early assignments, and as we go on, you'll end up memorizing it as you do more problems. But don't worry about memorizing it yet. Okay, so this fraction setup is what we're going to be using in order to solve our stoichiometry problem, basically figuring out how much H2 is being made right now. All right, so in this first blank, what we're going to do, I want you guys to label it. You always put your starting number from the problem into this first blank. Okay, whatever your starting number is from the problem, you put it into the first blank. Okay. All right, now if you guys take a look at the problem, this is usually how much chemical you start out with. So if you guys look at the problem, it tells you that we started with 10 grams of zinc. So what we're gonna do is in this blank, we're gonna put 10 grams, and then we're gonna label it as zinc, Zn. Okay, so that's our starting chemical. We are given it in the problem, and then if you guys look at what we did, what we're doing in the front right now, the zinc is the thing that we started off. It was 10 grams of zinc in here. That's what we put into that first one. And if you guys notice, the balloon is expanding. It's the reaction is running. Okay. All right. Any questions on this first blank? That part's pretty easy. All right. Let's go to the second blank. The second blank, we are going to fill in the blanks using the molar mass of your starting chemical. So whatever you start with, you are going to use the molar mass of that starting chemical to fill in the blanks here. All right, so let's see if you guys are paying attention. What is our starting chemical? Zinc. Great. So we're going to label this whole thing as zinc. Good. And I'll color code it just to help you guys see it. But this fraction is all going to be about zinc. And then you guys can see a lot of H2 is being made. So the reaction is kind of going right. All right, so if you guys take a look at what we did in the warm-up, you guys notice how we found the molar mass of zinc already, right? We found that it's 65.39 grams in 1 mole. What we're going to do is we're going to use this, what we found, the molar mass, and we're going to plug it in to this fraction. So if you guys take a look at the top, we have moles, right? If you look at the molar mass, what's the number in front of moles in the molar mass of zinc? What's the number in front of moles right here? 1. So we put a 1 right there. Okay, that's too much. Stop it right there. Yeah, so that smoke is the H2 that is being made. All right. All right, guys, a little pause. So we put a 1 in front of moles because molar mass is 1 mole. Everybody good with that? Okay, so if you look at the bottom, we have grams, right? What number is in front of grams for the molar mass of zinc? Yeah, so we're going to put in 65.39 on the bottom. Okay, so you guys can do that first while I figure this out. Great. And the one cool thing about H2 is it's lighter than the air around us, so it floats. It's like helium, kind of. Alrighty, can you hold on to this? Please don't let it fly to the ceiling. All right, so that is the first fraction. All we're doing is we're putting in the molar mass of the starting chemical. Everybody good with that? Okay, let's move on to the second fraction. Now, the second fraction, we are going to get the numbers. It's kind of a combination of the two. We're going to find the numbers from the balanced equation. Okay, we're going to get the numbers from the balanced equation. All right, now, on the bottom, you are going to put the number for your starting chemical. So our starting chemical is zinc, right? So we're going to label the bottom as zinc. And then on the top of the second fraction, we're going to use the number for what you're looking for. So if you look at the problem, what chemical are we solving? H2, perfect. So we're going to put H2 on the top. Good. Okay, so just keep that in mind. The second fraction, the starting chemical will go on the bottom, and the ending chemical, what you're looking for, goes on the top. Okay. All right, so all we're going to do is we're going to look at the balanced equation, and we're just going to look for the numbers in front of these chemicals. So we look at Zn. What number is in front of Zn in the balanced equation? 1. So all we got to do is put a 1 on the bottom. Easy peasy. And then in the balanced equation, what number is in front of H2? 1. Perfect. All right, so we're done with the second equation. All we got to do is the last fraction and then just plug it into our calculator, and we'll be all done. All right, now the last fraction is kind of the opposite of the first one. We're going to get the numbers from the molar mass, but it's going to come from the molar mass of your ending chemical, what you're trying to find. So we're trying to find H2. So we're going to put the numbers for H2 in this last fraction. Alrighty, so we already found the molar mass of H2 in the warm-up, right? So we're just going to plug in our numbers. Now, I do want you guys to be careful, though, where grams and moles are on the fraction. You guys notice grams is on top of this last fraction, right? So what number should we put on the top of this fraction? Exactly, 2.02. So just keep that in mind. If you guys remember, grams on the bottom of the first fraction, but it's on the top for the last fraction. So you got to keep that, keep track of that. And on the bottom, we put 1 because of 1. All right, and congratulations, guys. That is the setup for stoichiometry. If you understood that and you're able to do that on your own, the labs, tests should be pretty easy going forward. Okay, but I do want to mention, I know there's a lot of numbers and work. Going forward for your assignments, you guys need to write all this down and submit it. You can't just give me the answers because in the long run, it'll help you guys out. I know it's a lot to write. It's kind of tedious and annoying, but I promise you this will help you get the right answers. Yeah. Yeah, I would recommend for the assignments going forward, you do it on a piece of paper and just submit the picture of it. Yeah, if you want to type it out, you can, but a lot of people don't like doing it, so I'd recommend just writing. Good questions. All right, any questions about the setup? Okay, now we just have to do the math, okay? So the math, the rules are the same as before. All the numbers on the top you are going to multiply, and all the numbers on the bottom you are going to divide. Okay, so I'm going to write down what you should type into the calculator. You can write it down if you want a reference, but you don't have to. But we're going to take our starting number, which is 10, okay? So we're going to write down 10 in our calculator. We go to the first fraction. We multiply by 1, but, I mean, that's going to be the same number, right? So you can ignore the 1. There's a 65.39 on the bottom. So on your calculator, you're going to punch in 10 divided by 65.39 because it's on the bottom. That's the first fraction. Second fraction, there's a 1 on the top and the bottom, but we can ignore that because if you multiply or divide by 1, you get the same number. And then the last fraction, we have 2.02 on the top. So we're going to multiply that by 2.02, and that will give you your final answer. Okay, so plug that into your calculator. Let's see if you guys get this right answer. Do a little calculator practice. And I'll give you guys the answer in just a second. All right, guys, so if we plug it into our calculator, again, starting number is 10 divided by 65.39 times 2.02, and our final answer is going to be about 0.3. I'm going to do 0.308, okay? And again, remember that starting now, our numbers might be a little bit different, but as long as you're in the right ballpark, similar numbers as me, you should be fine. So 0.308, but we need to label our number. And the label will always be grams of whatever chemical you were looking for. So grams of H2. And that is our final answer. Okay. All right, so what all that is telling us, guys, is that when we started with 10 grams of zinc in here, and then we added the H2, we added HCl and we made H2 gas, right? That means we made 0.308 H2 gas. So that's what's in here. We calculated how much gas we made using our 10 grams of zinc. That's what stoichiometry is. It's finding out how much you made using your starting chemical. Okay. All right. Any questions? I'm sure there might be some. There's a lot. But what we're going to do now is we're going to take this H2 gas and we're going to use it for another reaction. Anybody need time copying this down still? Okay. So we're going to do one last problem together. But before we do that, I'm going to show you guys what this looks like when you react it. So in here is H2 gas. And what I'm going to do is I'm going to react it with the oxygen and the air around it. So while I prep, I want you guys to copy down that problem, because you're going to be solving that next, and then I'll prep to show you guys what that looks like when you react to the oxygen. Yeah. Wait, I really didn't do this for you. All right, so I got the balancing for you guys. That part hopefully is not too bad. 212. Okay, now let's do the molar mass for the important or involved compounds. Now, the starting number, if you guys notice, is 0.308 grams of H2. That means our first chemical that's important is H2, which we need to find the molar mass of, and we did in the previous problem, right? H2 was 2.02 grams in 1 mole. All right, our second important chemical is the one that we're looking for. It says excess O2, so O2 is not important. We don't need to worry about that. Okay, but it says the question's asking how many grams of H2O will be produced. So we are looking for H2O, and so you should have found the molar mass of H2O. It's 2 H's and 1 oxygen. That'll give you 18.02 grams in 1 mole. Okay, so if you guys got that, you are on good shape. All right, any questions on the balancing molar mass? Okay, let's go to the actual stoichiometry now. So we're going to use the exact same setup as before, and we're going to plug in the numbers in the same way, okay? So if you guys remember, this first blank is going to be with our starting chemical. So it's going to be the 0.308 grams of H2. So we're going to plug in 0.308 grams of H2. So that's the first step. Now, the first fraction is going to be the molar mass of our starting chemical. Okay, so our starting chemical is H2, so this whole fraction is going to be about H2. And if you guys look, we found the molar mass of H2, which is 2.02 grams. Now, we got to figure out where to put the 2.02, top or bottom. Where should we put it? Yeah, the bottom, because that's where grams is. It's 2.02 grams, so we put 2.02 on the bottom. Okay, and that's why, if you guys remember last time we met, I told you to label the numbers, and this is the reason why. Because if you don't label it, you don't know whether to put on the top or bottom, and then you'll get a completely different answer. And on the top, we put 1, because it's 1 mole. Thank you. All right, any questions for that first fraction? Okay. Second fraction, we get the numbers from the balanced equation. And if you guys remember, the bottom of the balanced equation is our starting chemical. So we're going to put H2 on the bottom, because that's what we start with. And then on the top, we put the chemical we're looking for, which is H2O. Okay, so again, second fraction is the balanced equation. And on the bottom, we put our starting chemical, which is H2. And on the top, we put our ending chemical, which is H2O. All right, so if we take a look at the equation and we look at H2, you're going to notice there's a 2 in front of H2. So we put a 2 on the bottom. And the H2O also has a 2. So we put a 2 on the top. That's the second fraction. All right, any questions on that one? All right, let's go to the third fraction. The third fraction is going to be about the molar mass, but this time it's going to be for the ending chemical, which is H2O. And then if you guys look, 18.02 grams, and then grams is on top, so we put the 18.02 on the top, and then it's 1 mole, which goes on the bottom. There you go. That is the entire setup. Now, I do want to mention, for your exams, you will have questions like this, and there is partial credit. If you can get this entire setup, but let's say you just mess up on the calculator, you will still get most of the points, okay? The setup is what I'm really looking for, is that you understand how to set it up. So just make sure that you guys really get this process down, because that's where most of the points will be, yeah. Yeah, because molar mass is always 1. If it helps you just to memorize it, the bottom of the third fraction and the top of the first fraction will always be 1. So if you want to make a note about that, this spot and this spot will always be 1. Okay? All right, let's plug it into our calculator. So if you guys remember, all the numbers on the top we multiply, all the numbers on the bottom we're going to divide. I will give you guys about a minute. See if you guys can plug it into your calculator. See if you can get the final answer, and see if you guys can label it properly. Okay, so remember that label we put at the end, grams of whatever. Let's see if you can get the number and the label properly. We have one last thing after this, real quick, and then we'll be all done. All right, so I'm gonna pull up my calculator here. So our starting number is 308. The 2.02 is on the bottom, so we're gonna divide by 2.02. There's a 2 on the top and a 2 on the bottom, so we're going to do times 2, divided by 2. And then there's an 18.02 on top, so we multiply by 18.02. And our final answer will be 2.7, I'm going to round it to 2.74 grams of H2O. And if you guys got that, great job. Stoichiometry should be pretty easy for you guys. Okay, so when we blew up the balloon with the hydrogen gas, reacted with oxygen, we made 2.74 grams of water, which is why you guys couldn't see it. It's so little water that you can't really see it. All right, and that's it for the calculations. Any questions about this whole setup? I know this is a lot, which is why we're going to spend actually a good amount of time before we start our first lab with this. I think we have like 2 class sessions where we're just going to work on the Stoich practice, and then we're going to jump straight into the lab, which means our first lab is the end of next week. Okay? All right. Now, there is one last thing, one last component of this that we are going to go over. And it's going to be, we're going to be writing a sentence describing what happens here, because we want to put some words to this math so we actually understand what's going on. Okay, and it's pretty simple. The way that you write a sentence describing what's going on, and this is actually part B of your problems on your assignments, is you're going to start with the chemicals that you have. Okay, so our starting chemical is H2. We're going to write down how much H2 we started with. So 0.308 grams of H2. So make sure you're writing this down. This is the second part of the problems you'll get. And then we're going to write reacts with excess O2. So H2 reacted with the O2. And then we're going to write to produce, and then our final answer, 2.74 grams of H2O. Okay, so this sentence describes what this math is all about. It's telling us that you started off with 0.308 grams of H2, it reacted with excess O2, and then you made 2.74 grams of H2O. And that's pretty much the answer you got at the end. Okay. Okay, so you're basically answering the question that's being asked with words now. Okay, you did the calculations, and then you're just answering the question with words. Yes. Yeah, or where it asks you to. I think for today's assignment, they all have write a sentence describing it, so you'll have to add. You do have an assignment.